Now, today we are going to start a new chapter, chapter 7, lesson 2, which talking about principles of integral evaluation. Lesson 2 is talking about integration by parts. Now, in integration, we have two types. We can integrate and functions by, and if I have cosine times sine as an example, we can use two ways. We can use integration by substitution and combination integration by parts. Integration by substitution, by use substitution, as we discussed in chapter 4, that sometimes if you look at the two functions such as sine times cosine, when they are like this, you can say this is u, then you find du, then you will integrate. This is for the sine. So I mean, like, if you have integration of two functions that are multiplied, such as sine of x times cosine of x, and you need to integrate them. In this case, you said before that this is u, and then you find du, then you will substitute it as u, integration of u times negative du, then you have it as negative u du, then you will integrate. This is way we call it integration by substitution. Today now, if we have two functions that are multiplied, but you cannot say that this is u and this is du, because if you, in the previous example, if you say that if this is u for cosine, if you find its derivative, it will be sine. But x, yeah, I mean there's a relation between sine and cosine, between x squared and 2x. If you define the derivative of x squared, it will be 2x. So you can substitute by du. But if you have x and cosine, logarithm and cosine, logarithm and tan, ln and cosine, and so on, you cannot say that the derivative of cosine is ln or the derivative of logarithm is sine. In this case, you have to use something, we call it integration by parts. So if I say the function that I can say that this is u, and I can find the derivative of u and evaluate cosine with du, I call it integration by substitution. But sometimes I cannot say that this is u and I find its derivative, I say it is cosine. This cannot be. In this case, we have to use something, we call it integration by parts. Is it clear now what's the difference between them?
Yes, teacher.
Yes, teacher.
What is the formula for the integration by parts? There's no u substitution here. There's a formula. The formula is, if you have two functions like f of x and g of x are multiplied, and you want to integrate them, first step, you have to assume that this is u that you have to say that this is u and the second one is dv. The first one is u and the second one is dv. And then if you have u, you have to find its du. And if you have dv, you have to find its v. So the first part, we call it u, and the second one, we call it derivation of v, dv. For u, you have to find its derivative. And for dv, when you integrate it, you can find v. So here you need two things, integration and derivation at the same time. For u, you will find its derivative in order to find du. And for dv, you have to find its integration, because I told you before, an integration is an inverse of derivation. So they cancel each other to find v. After this step, you will come back here. The formula or the answer will be u times v minus integration of v du. So integration of u times dv, two functions that they are multiplied, u times v minus the integration of v times du. You evaluate now. What did you have in the formula here to get the answer? Yeah, let's see now this example here. Use integration by parts to evaluate an integration of x cosine x dx. So here we have to find an integration of x cosine x. Now, the first step, assume that this is u and this is dv. This is the first step. Then, come back here now. Say u is x and dv is cosine of x. And then, for u, you have to find its du, and for dv, you have to find its v. So I have u is x. So for u, you have to find the derivative.
du,
So if u is x, so you have to find now it as du. I mean the derivation of u will be 1. And since I derivate to x, I have to say dx. So this is u and this is du. Now then, dv is cosine. In order to find v, as I told you before, you have to integrate. So here, in this part here, you have to integrate. So when you integrate dv, you have v. So now what's the integration of cosine?
sine,
It is sine.
Sine.
So I have now u, du, v, and dv. After I fill now my bag with u, du, dv, and v, I will come back now to my integration here. Now let's remember that. When you need, let's remember our formula. That's when you need to find the integration of u times dv. Let's write it here first. It will be u v times an integration of v times du. So now let's write that. Now where is u here? U is x. So the answer will be x times v. Where is v? It is sine x. So it is x sine x minus integration of v. Where is integration? Where is v? It is sine. So integration of sine of x times du. Where is du? It's dx. Let's repeat. U, this is u, times v, which is sine, time minus. So u times v, then minus the integration of v. I will repeat v next time, yani, second time. Then my times dx, times du, sorry. Where is du? This is du, which is dx. Then, and I will not finish, I didn't finish here. I will continue. So here we have x sine x, it's already simplified, but minus integration of sine x. I cannot keep it here as a minus integration of sine. You need to find the integration of sine with respect to dx. Integration of sine is negative cosine plus c. So the answer will be x sine x plus cosine x plus c. This will be here the final answer. Is it clear?
Yes, teacher.
Yes, teacher.
Now, let's have another example, such as x squared cosine x or x squared sine x. Integration of x squared sine of x dx. As I told you, this is u, and this is here dv. And then u is x squared and dv is sine x. For u, you need to find its du, which is 2x. And for dv, you need to find its v, which is the integration of sine, which is negative cosine of x. This is a hard one. So please, I want to make something here. This case, we keep it later on. So let's imagine now that this is here 3x. You need to find now the integration of 3x times sine. So if u is a 3x, du will be 3 dx. So here, this is u, this is du, this is dv, and this is v. After that, let's remember that the integration of u dv will be uv minus the integration of v times du. In the formula, in order to memorize it, u times v, then for v, you have to find its integration, and for u, you have to find its derivative. Change the order of them and change the inverse, write the inverse of them. Then here now, u times v, where is u? It's a 3x. Times v, where is v? It's negative cosine x. Minus integration of v, which is negative cosine x, times du, which is 3 dx. Then let's rewrite it now as negative 3x cosine x plus 3 and integration of cosine x dx. Here now we have an integration of cosine. I will continue. So negative 3x cosine x plus 3. Now what's the integration of cosine?
Sine.
Sine of x plus c. So here, this will be now the answer. Integration of 3x sine x will be negative 3x cosine x plus 3 sine x plus c.
Teacher, from where we get the 3?
Here, it's a 3x.
Why it is plus 3 cosine x?
Here, I told you that the formula is v du. Now, where is du? This is du. 3 dx. And v is negative cosine x. So you get this 3 outside the integration. Then you integrate.
Okay, thank you, teacher. Now here, so this is in this part here, we are going to talk about if I choose that the first one is u and the second one is dv, or the first one is dv and the second one is u. Does it matter? When I choose u and when I choose dv. The main goal here in integration by parts is to choose where's u and where's dv. In general, there's no hard and fast rules for doing this. Just ask yourself that. Here, look at this part here, which is the very important one. A strategy that often works is to choose u and dv when I found that, look at here, which one is easier to me to, if you have x cosine x. Ask yourself, now which one easier or simpler to me to find its derivative? X ولا cosine?
X.
X.
So the one that I found that is simpler to me to find its derivative, I name it with u. While leaving a dv that can be readily integrated to obtain v. So just ask yourself, which part is easier to me to find its derivative? Because the derivative is the hard one. Sometimes you have power rule, chain rule, you have some complicated things. So ask yourself, which one is easier to me to find its derivative in order to see where is u and where is dv. Now let's see that for the first example here, which is x cosine x. We said that x is u and cosine is dv. Let's see now if we put an x as dv and u as cosine. Let's change them. In the first case, we said that x cosine x, we said that this is u and this is dv. Now I want to solve it to you that if we say that, if I want to make this is u and this is dv, can I? Yes, you can. But let's see now how it will be complicated. First, let's remember, for u, you have to find its derivative, which is negative sign. And for dv, which is x, you have to find its integration, which is half x squared. Then the formula is integration of u times dv is u times v minus the integration of v du. So it will be u, which is cosine of x, times v, which is half x squared, minus an integration of half x squared times negative sign of x. So we have it as half x squared cosine x plus half integration of x squared sine x. For this case here, if you look at this part, we will use that is integration by part another time. We will have to say that this is u and this is dv, and then we continue. And sometimes we cannot stop. That's why I told you, when you want to find an integration, just say which is easier to me to find its derivative. Derivative, yes, x. So this is my u, and the second one will be dv. If you change them, you will get an answer, yeah. But here, I mean here, why it's complicated. Look at the answer in the rectangle here. In this part here, you have x sine x. They are multiplied, and I cannot use an integration by substitution. I have to use the integration by part another time. And then say u dv, and then do the same steps as I did here in order to find the integration. So to solve this problem, just say x is easier or simpler to me to find its derivative. This is my u. Is it clear?
Yes, teacher.
Yes, teacher.
Let's solve now another example. X, ex. Here, let's say that I want you to solve it by u substitution. That this is my u, and this is du. I cannot find the derivative of x as e of x. I want to find it as like this. And for e of x, its derivative, if I say that this is my u, so here, this cannot be cancel x, so I cannot use u substitution. I need now to go to the second part of the second type of integration, which is integration by parts. Because here I have a linear, or you can say linear with an exponential or natural logarithm function, natural exponential function. Two different types, so I need to use integration by parts. So integration of x e to the power x dx. Now, which part is easier to find its derivative, x or e to the power x?
X.
X. So this is u, and this is here dv. Then I will write here, if u is x, I need to find its derivative, which is du, which will be dx. And if e to the power x dx is dv, I need to find v. Now, what's the integration of e to the power x?
E to the power x plus c.
E to the power x. So after I have now this here, u is x, du is dx, e to the power x is dx, or e to the power x dx is dv, and v is e to the power x. After I have these ones here, let's now come back. Let's remember that it is u v minus integration of v du. Then u times v, this is u, and this is v, minus integration of v times du, which is dx. So x e to the power x minus
Now, what's the integration of e to the power x? It is e
Power x.
plus c. This here will be the integration of x e to the power x. The answer is x e to the power x minus e to the power x plus c. Is it clear?
Yes,
Yes,
teacher.
teacher.
Now, evaluate an integration of ln x dx. Here, in order to find the integration of ln, I can say that this is my u. Now, where is dv? I
Is
will say
dx.
dx will be dv. So here, integration of ln x dx, I will assume that ln of x is u and dx is dv. If there's nothing here beside the u, assume that dx is dv. Then, let's say that if u is ln of x, so du will be, what's the derivation of ln? 1 over x.
Or x.
And then if dx is dv, so the integration of dv, which is v, will be x. So I have now u, I have now du, I have now integration of dx, and I have now v. Then let's remember that the integration of u dv will be u times v minus the integration of v du. So u, which is ln of x, times v, which is x, minus integration of v, which is x, times du. Where's du here? It's 1 over x dx. Then x ln x minus. Here I have defined an integration of x times 1 over x. Before you integrate, check that if you can simplify. Yes, I can simplify them as 1. So it comes like integration of 1 dx. Then, so the answer will be x ln x minus, what's the integration of 1 dx? Integration of 1 with respect to x.
X.
X, bravo. Integration of 1 to respect to dx is x plus c. So this will be here, integration of ln will be x ln x minus x plus c. Is it clear?
Yes, teacher.
Teacher.
Do you have any question?
No, teacher.
No, teacher.
Okay. I will stop here today. Tomorrow, inshallah, we will continue. We will solve some extra examples to find integration by parts. Thank you so much. Have a nice day.
Teacher.
Thank you, teacher.
Thank
Have a
you.
nice day.
Nice day.